Hello my dear VLSI aspirants, welcome to Deep Silicon VLSI YouTube channel. In this video we are going to discuss about the design challenges with respect to functions. Yes, instead of giving the inputs just like a variable a, b, c, p, q, r, here the inputs are functions and what will be the output function or any one of the input function by giving the output function. There are different kind of models in this particular topic. Okay, without any delay, let's enter into the question. Consider 4 variables functions f1, f2, f3 which are expressed in sum of minterms as f1 is equal to sigma of 0, 2, 5, 8, 14, f2 sigma of 2, 3, 6, 8, 14, 15, f3 sigma of 2, 7, 11, 14. For the following circuit, the output can be expressed as this one, guys. For this, you need to know about Venn diagrams knowledge. Once you understand the Boolean algebra Venn diagrams concept, it is so easy to handle this question without any delay, without any strugglings. Yes, and for better understanding, we are giving you the link in the description regarding the Boolean algebra Venn diagrams concepts. Once you go through it, so that you can understand and you can challenge any kind of question similar to this very easily. Right now, let's see, guys. Coming to this f, what it is? This is a AND gate. It is f1 into f2, and this will be f3. Now, guys, here the expression is f1 f2 XOR f3, isn't it, guys? Now coming to the AND operation, guys, if it is f1 into f2, that means exactly speaking that is f1 and f2 only. Okay, exactly speaking, it is not f1 into f2, it is f1 and f2. Remember. Now, if you take the Venn diagrams concept, then obviously, guys, if there are 2 variables and we want to take, let's assume this is f1, this is f2, and you want to know f1 and f2, what portion we need to consider? This one, the common portion only, f1 and f2 only now. Similarly, if it is f1 or f2, we will take a union b. f1 union f2 means everything regarding f1 and f2. So here remember, f1 and f2 represents the common portion present in both function f1 and function f2. Therefore, you see here, that is f1 and f2. What are the common minterms here? 2, 14, isn't it? Of course, 8 as well. 2, 8, 14. Hence, f1 and f2, which is f1 into f2, is sigma of 2, 8, 14. Got it? Similarly, let's assume this is f1, f2 and we need to do XOR operation. Again, guys, you take one XOR operation. Let's assume this is A, this is B, A, B. Then, guys, what is A XOR B? That is A bar B plus AB bar. Where you get A bar B, guys? Here only, na? Similarly, A B bar. Of course, this is A bar, like A B bar, this one, and that will be A bar B. This one, guys. So, in the Venn diagram from this, what you can analyze is, in this Venn diagram, XOR operation means you need to separate the common terms and remaining terms you have to take. That is what XOR operation. Here A is there, B is there. you are not taking the common terms. Other than the common terms present in both A and B, we are taking. The same analysis now you have to apply. Now guys, this is F3. This is the resultant 2, 8, 14. Now what to do? We need to follow XOR operation now. For XOR operation, the common terms you need to exclude and the remaining terms present in both the functions we need to consider. That's it. It is so easy. Okay. Now let's see here. It is common terms 2, 14, 2, 14. Then obviously exclude them. Hence here F will be sigma of the remaining terms 7, 8, 11. 7, 8, 11 guys. That's it. Once you understand XOR operation through Venn diagram, AND operation, even OR operation also. If there is a OR operation, you need to consider all the terms because A union B is A or B, no? A and B is A intersection B. For that I have told you, for this you need to have Boolean algebra, Venn diagrams concept. You check it in the description, you will get the link so that you can understand very clearly. Right guys, this is what here the identification of the function in terms of min terms for a given functions which are present in the min terms. Right? I hope you like the video, and if you are first time visiting our YouTube channel Deep Silicon VLSI, please guys subscribe our YouTube channel and extend your support. Yes, we are listening. Please give your inputs. We work on it and we will give you the best of the best VLSI content. Sure. See you in the next video. This is Shivram signing off. Jai Hind.